Okay, so our claim is that if A and B are non-zero vectors in n space, then the dot product between them is just the product of these three things: the magnitude of A, the magnitude of B, and then cosine of theta, where theta is the angle between them. Okay. So we said in the last video we were going to have three different cases, and case one was going to be that A and B were non-zero vectors so that the angle between them was 0. And that means that they're pointing in exactly the same direction, and so then A is just equal to K times B for some real number K that's greater than 0. Okay, it's got to be a positive scalar multiple in order to have the same direction. Okay. All right, I want to prove that this equation is true. I could write that out as my claim. I think I'm just going to work out what the left side is and what the right-hand side is. I've got it up here, so I don't need to copy it down here as my claim. But I can say then that A dotted with B is equal to KB dotted with B, okay, which is just going to be K times B dotted with itself. That was one of our properties of the dot product. Now, I'm not actually providing reasons here. I did not specify that we were doing this proof in painstaking detail. So I am going to go one step at a time. Generally, I'm going to ask you to do your proofs in this painstaking detail if you need to break things up into the component level. This proof, it turns out, we can do without the component level. Okay. Notice this is just the magnitude of B squared. That was another one of the properties of our dot product. Okay. So this would be the left-hand side of this equation simplified. Okay. So now let's take a look at the right-hand side. Okay. So if I look at the magnitude of A times the magnitude of B times cosine of theta, that's going to be the magnitude of K times B times the magnitude of B times cosine of 0, because we said that the angle between them was 0. Now, when we talked about magnitudes, we talked about what happens when you scale a vector by a number. I do want to be careful here. What I get when I simplify this is the absolute value of K times the magnitude of B. Okay. So this part right here is simplifying that first factor. The magnitude of B is fairly simple, and cosine of 0 is just 1. Okay. So I've simplified each of those three factors. Didn't really have anything to do with the middle factor, but I simplified this and simplified this. Now, what's the absolute value of K? Well, we'd stated that K was positive. So I can say because K is greater than 0, the absolute value of K is just K, and then this is the magnitude of B squared times 1. Now, I am going to insist on having that reason, and here's why. I've had lots of students who have been showing some work and they have an absolute value somewhere, and then poof, it's gone. And sometimes it's clear that the reason the absolute value went away is because the student didn't know what to do with it and so just decided to pretend it wasn't there. That's very different from knowing that K is positive, so that we're actually evaluating the absolute value of K and saying that absolute value is equal to K. So when you are working with absolute values, if you have just a number, you can go from the absolute value of 2 to 2 with no explanation. But if you're taking the absolute value of a variable, and that variable happens to be positive so that you can just drop the absolute value, I want to see that explanation. Because I can't tell the difference between you thinking, oh, K is positive, so the absolute value evaluates to K, and you thinking, oh my goodness, there's an absolute value, I don't know what to do, I think I'll pretend it's not there. And I have seen students do both of those things, so make sure you tell me that you're doing the right thing. Okay, notice I got exactly the same thing in both cases. This is sort of like the 3-paragraph method. It's just that I didn't identify things as the left or the right-hand side. I've got a little bit of room here, so I'll just say, thus, A dotted with B, which is what I simplified here, is equal to the magnitude of A times the magnitude of B times cosine of theta, which is what I simplified down here. Okay. So our claim holds in case 1. Let's take a look at case 2. Now, case 2, my vectors are still going to be parallel, but this time they're going to point in opposite directions so that the angle between them will be negative. So case 2, let A and B be non-zero vectors such that theta is pi. So they're pointing in the opposite directions. And I can say, well, then what that means is that A is equal to K times B for some real number K, but this time K will be less than 0. Because if I multiply B by a negative scalar, I'm going to reverse the direction. Okay, so I'm going to just simplify the two sides again. So A dotted with B is simply going to be KB dotted with B, which is going to be K times B dotted with B. That was one of our properties of the dot product, which is going to be K times the magnitude of B squared. That work is actually exactly the same as what we had in case 1 just a minute ago. Let's look at the other side. The magnitude of A times the magnitude of B times cosine of theta will be the magnitude of KB times the magnitude of B times cosine of pi. So now I'm going to simplify those factors. Once again, this becomes the absolute value of K times the magnitude of B. This middle factor is just the magnitude of B. And cosine of pi is -1. Okay. So last time we were taking cosine of 0 and we got +1. Now I get -1. Okay. So let's see. What's the absolute value of K? Well, it's the opposite of K times the absolute value of B. And that's because K is a negative number. Now, a lot of times students don't like this because they see absolute value and they say, wait, absolute value can't be negative. So how can there be a negative sign when I evaluate it? Well, I'm not saying that this is a negative number. I'm saying K was a negative number. The absolute value of K is therefore the opposite of K. Very helpful to read that as opposite rather than negative. Because if I read it as negative, I'm thinking it means something negative, but it actually just means the opposite of K, which is a negative number. If you think about it, let's actually take a quick look here. If I look at 2, I can say, that is a positive number. And I know that because there's no negative sign in front of it. But if I look at a variable like K, it's not clear from the presence or absence of a positive or negative sign whether it's positive or negative. I was told that in this case K was negative. And if I have a negative number, like if I have -5, absolute value of -5 is the opposite of -5, which is +5. Okay, so we get that, and then we've got the magnitude of B, and then we've got this factor of -1. Well, this factor of -1 and this factor of -1 will cancel each other out, and so we'll be left with K, which happens to be a negative number, times the magnitude of B squared. Okay. And just like last time, that's exactly what we got when we simplified the left-hand side of our formula. So I can conclude, thus, A dotted with B is equal to the magnitude of A times the magnitude of B times cosine of theta. So the formula works in the two cases where A and B are parallel vectors. Now, the most interesting case is going to be case 3, where they're not parallel to each other. But if they're not parallel to each other, I can form a triangle. And so we'll take a look at that in the next video.